So for the next one, I'm going to move into the world of high fashion. So I started hearing about microservices from various colleagues of mine, about a year and a half ago, 2 years ago, I can't remember now. And like many of these things, it's because I don't do any real work anymore. I just try to listen to people who do. So I hear some talking about something, and I go, oh, that's kind of sound of interesting, a little bit weird. And then I kind of listen a bit more, and once I begins to reach a certain amount of it's been around for a bit and I'm getting enough chatter on it, I think I need to try and figure out what this thing is and try and understand it. So I'll begin by quickly by giving the kind of the high-level explanation. At a very high level, it's a contrast between two styles of building software. What the microservice people refer to as the monolithic system is really saying we're trying to build all the capabilities of the people's piece of software and get it to run as a single executable, a single process, in a single, I mean, I'm being kind of vague with words like process and executable, but that's basically the idea. There is one kind of thing that has all the capabilities within them. Well, microservices try to split this up and say, let's take every individual capability of a piece of software and put it in its own process, and so that they all talk to each other with inter-process communication things, such as RESTful HTTP or some simple message queue or something of that kind. And then when we wanted to distribute and deploy this software, with a monolith, we have to take the whole thing and copy it to many servers. While with the microservices, we can place them on different services according to different needs. If one capability is required more, we can put it on more servers, etc., etc. We have more flexibility of deployment. Many ways similar to service-oriented architecture. I'll talk about how I see the difference between the two later on. But that very broadly is what I was hearing about microservices. Now, as I said, that leaves open a lot of questions. You get a feel for what it is, but not much more than that. So I thought to myself, can we get a bit further? I would like microservices to have a definition. And this is partly because of the fact that one of the problems I saw with service-oriented architecture was it was ill-defined right from the very beginning. And that caused a lot of confusion. And I like to have definitions of things to say, I can clearly see whether something is one thing or another. But the problem, of course, with terms like this is it's almost impossible to come up with a definition of them. I just spent a while writing a book on NoSQL databases. And again, that was a very, very ill-defined kind of thing. You can't come up with a concrete definition because we don't have some official body of computing vocabulary that comes up with definitions of things. I mean, I would very much like to be that body, especially if it's only me that's on it, because the arguments are much easier to settle that way. But it doesn't exist. And instead what we can say is, well, maybe we can't get a definition, but we can identify common characteristics. And so what I did is I sat down with my colleague James Lewis, who's been very much into the microservices camp over the last couple of years, and we wrote an article that's on my website that talks about the characteristics of microservices. And I'm going to go through some of these. We identified 9 common characteristics. And I haven't got time to talk through all of them in my little 20-minute format, but I'll highlight some that I think are particularly interesting. And I want to stress these are not sort of hard definitional items in that every microservice architecture exhibits all of these things. They're common characteristics. So the way I think of it is most microservice architectures have most of these characteristics, but there's always going to be a certain amount of variation. So the first one, componentization via services, is in some ways one of the most subtle ones. And it really comes down to this notion of what we think of as a component. I've been active in the software industry for 20 plus years now, and we've always talked about components. Some people say, well, objects are components. I remember at one point Accenture changing their object systems group to a component systems group because component was the more sexy name at the time, and thinking, well, they're the same kind of thing. And it has a lot to do with we're trying to modularize software into smaller boxes that you can kind of plug together more easily. But does that mean a component is the same as a class or some kind of modular structure in our software, what does it actually mean? And to me, the definition was broken down very nicely by Ralph Johnson when he said, well, it's not about necessarily how we think of the software as we're building it, but how we want to see how users want to relate to the software. They want to relate to the software like they do their stereo, where you can just take a box and replace it and plug in a new one. And so the idea is that a key element of what makes a component is that you can replace it independently. You can say, I don't like this piece, so I can get rid of it and bring in something new. And a corollary to that, which is actually more common in software, is that we can upgrade it independently. That is, I can decide when I need to upgrade this bit, I don't have to upgrade everything else. In fact, it's far more common that we'll independently upgrade than we'll actually replace. And when we have components, there are two broad ways we can go about doing it. One is we can bring in libraries, jars in the Java world, gems in the Ruby world. Every kind of language environment has them, where we can take a library from a third party and we can bring that into our software. We use whatever our language's environment's call mechanisms to call that library, but that library effectively becomes part of our single executable. And we do that all the time. We bring in libraries. In fact, one of the nice things that's happened over the last 20 years in software development is libraries are so much more common now. You know, I can usually grab a library for things where 20 years ago I'd almost certainly be forced with writing it from scratch. Services are very similar, except instead of bringing them into my executable and using in-process calls, I make remote calls between different executables. And that's really all it is, that when we think of how we componentize our system, we do it by these separate process services, rather than using libraries. Another important characteristic is the organization of the teams and the services that they build are around business capabilities rather than about infrastructure. So in many organizations, people will organize around a particular technology layer and things of this kind. When you see separations like this of people, that's a kind of technological separation. You might see this within a project, you might see this within a larger organization. The microservice point says, no, you want to instead have relatively small teams that are completely owning a business area. The often quoted example of this is that of Amazon, where it said that each team has to be fairly small. There are 2 pizza teams. They're American pizzas, so we're still talking about a pretty enormous piece of thing to food, but you're still talking about, you know, a dozen people or so. You're not talking about 50, you're talking about a dozen. And this is the point, and that point is well known, that you have your teams of that size. What often seems to be missed is, again, from what I got from listening to Amazon people, is it's very important that each of these teams has a direct communication right the way through to a customer and user. So each team has that connection. So if it's the team that's, for instance, to do with recommendations on the Amazon side, they're actually responsible for making sure that they see how that recommendation engine is used. The business side is channeled right the way through. And although I've seen lots of breaking people down into teams, that part of it, that it has to go all the way through to the end user, that is a thing that's often missed. So this brings in a very important fact that microservices is as much about a team organizational attitude as it is about a technological attitude. It's in many ways an embracing of Conway's law. Conway's law says that your software will follow the organization of the people choosing to build it. Or a common theme that you hear in microservices circles is, well, we actually want teams that are small, customer-focused, and relatively separated from each other. So we create that and force the software to follow that kind of view. So it's as much a team organizational thing as it is a software architecture thing. Because, of course, software architecture and team organization are always heavily coupled together. Anybody who denies that is leading themselves into trouble. If there's one universal law in software development, software architecture, I would say it's Conway's law. If you try to break it, it will bite you back much harder than you can try and force it. So, focus around business capabilities. Another very important thing is how we consider the smarts of how things should connect to each other. A lot of service-oriented architecture approaches that we run into in enterprises has the idea of various systems that communicate through a very smart infrastructure area, commonly something called an ESB. And the idea is that this central piece will figure out how to route messages from one thing to another, how to translate from this to that. We'll actually figure out, and often have the whole business process. You know, if you're going to have your workflow, you put it in there as well. The microservice approach very much rejects this and says, no, the pipes, the network must be dumb, all the smarts must live in the applications. All the network really should be able to do is say, tell me where this message has got to go, and I'll make sure it gets there. And so it's very much a dumb pipes approach. And this, I would say, is the biggest difference between microservices thinking and what a lot of people call SOA, is this focus on the smarts go to the endpoints, and there's no room for complex middleware and things of that kind. And this is, a lot of people find this very interesting because of the problems that we've had dealing with this complex middleware. It's often very difficult to deal with in terms of continuous delivery, for instance. I mean, I don't know whether it's still as bad as it used to be, but I certainly remember the days when ESBs could not be put under version control in any meaningful form. I mean, the closest I get is, oh, you can take a binary and throw it in Subversion. Well, that's really helpful, thank you. If it can't go in version control, then it has no business being any part of our development environment. That's my opinion. So smart endpoints. Another aspect is decentralization of the management, and in particular the data management. So while a monolithic approach will typically operate off a usually relational database, but the point is there will be a single database solution for the whole monolith. And in fact, it's usually worse than that. It's usually one database for many monoliths, but we won't go down that particular rat hole. The service-oriented approach says each service gets its own data storage and does not share that data directly with anybody else. Again, this is inspired by Amazon's example, where it was made a complete edict of their architecture that you never share data directly. All sharing has to go through the services that wrap the data. And so as a result, each service chooses what database to use. Not just the schema and things of a database, but also what kind of database. Do you want a relational? Is that suitable for what you're doing? Or would you be better off with some NoSQL flavor? Perhaps a document database or a graph database. Maybe you just use plain files in the file system. It's up to individual services what they do. And all communication occurs through the services that wrap those. That's an example of decentralized decision making. You don't have a central group laying out standards and deciding how things should be done, other than the very minimum connectivity things. You push almost all your decision making out to the individual teams so that they make those decisions. Infrastructure automation. Anybody doing microservices is really into the whole continuous delivery thing, for instance, because if you're going to do this kind of stuff, you want the services to be upgradable at any point. You've got to push them all out. So they do things like continuous delivery, blue-green deployment, which are techniques for being able to deploy new systems without any downtime. Phoenix servers, you hear phrases like that. A lot of infrastructure automation comes as part of the microservices world. And also the realization that things are going to fail. If you've got microservices, they are going to break. They're going to break frequently. Even to the point that Netflix, who are one of the major users of microservices, have this thing called the Chaos Monkey, one of my favorite tools of infrastructure, which is a tool that goes around and randomly stops services around their infrastructure. Just randomly, takes them down during the working day when people are monitoring, but the point is people are aware of the fact that things will break. They force the breakage to occur, and then they make sure that their monitoring and recovery is able to deal with it. Now, that's an interesting thing. If you're going to do microservices well, you've got to be confident that you could let a chaos monkey into your service area and you would be able to deal with it operating. And you should do that, because failure will happen with any large distributed system. And that affects everything. It doesn't just affect how you manage and run your servers, it affects how you design your code. You can't expect your remote service calls to necessarily succeed. Because one of the biggest problems with a lot of distribution strategies, such as distributed objects, was this notion of we can make a remote call look just the same as a local call. Well, there's many reasons why that's a completely bad idea. And one of them is local calls don't tend to fail, because the only way they'll fail is if the whole thing goes down anyway. But remote calls will. And so you have to decide, what happens when I get a failure? What am I going to do about it? How am I going to ride over that? What does it mean to me? How can I minimize the impact on the user? So there's a whole bunch of different things that come in here. As I said, this is I've just highlighted what I think are the most interesting characteristics here. So I've raised this question a couple of times. Are microservices just SOA? And I think the answer to this question really depends very much on what you think SOA means. For some people, SOA is what I've just described, in which case microservices is just a fancy new word that people are shilling on top of the old idea of SOA. And I quite understand that point of view. A lot of people have it, and I understand where they come from it. But there are many people who think SOA means the enterprise service bus, the very smart, centralized management, things of that kind. And to them, microservices is very different. So the way I tend to think of it is that microservices is a subset of what you might call SOA, a more firmly defined area in that subset. And I think it's a useful term because it calls out that particular style of SOA. But the unfortunate thing with the term microservices is that micro bit, right, which implies something about size. Any microservices person I've talked to keeps telling me that size is not an important part of what microservices is about. But with a word like microservices, it kind of forces it, doesn't it? You can tell I wasn't involved in coming up with the name. I would have come up with a much better name. So the question is, how big should microservices be? And the answer is actually there's a lot of variation as to how people take services. From, sort of 15 people, 10 services, 4 people, 200 services. I mean, that's a big difference. And it's not clear yet how that maps out in terms of usage. So having explained a bit about what microservice is about, we can then address the interesting question, which is when you should use a monolith and when you should use a microservice. And this is an important point because with any new idea, people tend to overuse it. And it's reasonable because when people have a new idea, they tend to push it because you don't really know where the boundaries of a good idea are until you've stepped over them and realized, oh, that was a bad idea. And then you know where the boundary is. And so it's natural that people will overuse it. And I've already heard of people overusing microservices. The great advantage of a monolith is that it's simple. That when I've heard people use microservices badly, what I've heard is, look, this will be a straightforward monolithic application, and they've gone and thrown a whole bunch of microservice stuff in it. And now we've got a distributed system, which is a big complexity booster. And often, in order to get performance good on a microservice system, you've got to use asynchronous messaging. Asynchrony is a huge complexity booster. Whenever you want to play the distribution card or the asynchrony card, you know you're increasing the complexity of what you're doing. It's often worth it. It's often necessary, but you've got to hesitate before playing that card. If you can't, my actual tendency is that this is big enough of a reason to say, if you're not sure whether you should do microservices, stick with a monolith, because it is going to be simpler. Microservices do give you an advantage of partial deployment. You don't have to redeploy your whole system. You can redeploy part of it. In fact, that was a driver for Netflix. They had difficulty deploying new versions of their software. That was one of the things that pushed them towards a microservice approach. Having said that, I do know of organizations that can successfully do regular deployments of even very large monoliths. So it doesn't have to force you to microservices. Microservices can give you a degree of availability. If you do your failure management well, one service can keep giving some degree of degraded but still useful work even if other services fail. And while with a monolith, of course, if anything breaks, everything breaks. But then, if availability is good, you know what that means. Consistency is probably going to be a problem. And yes, microservices, you would begin to enter the world of eventual consistency and all of that kind of stuff. I've got a whole other talk on that topic, but that's another complexity area that comes into play. Monoliths allow you much more easily to change the shape of the code. Because if I need to refactor and move some behavior from over here to over here, and I'm within the same code base, within the same executable, it's a relatively easy thing to do. If I've got now two different services, then it's much, much harder. And in fact, your service boundaries will really force early on. If you get your service boundaries wrong early on a microservice project, then you're going to find it very difficult to fix them. With a monolith, you have more maneuver for flexibility. So that's another argument for if you're not sure, stay with a monolith. And I should point out that many of the examples of relatively successful microservices that I've come across so far started with a monolith and then went microservices when they ran into trouble. That may not be the best way of doing it and just maybe historically the way people have done it, but the fact that that's most of the cases so far is interesting. Interestingly, as a kind of almost like a counter to this, you can actually be easier to preserve modularity with microservices. And that's because our programming languages actually don't do a very good job of forcing modularity. It's too easy to jump around the module boundaries. And so one of the criticisms people have of monolithic code bases is, well, it ought to be well-defined modules, but it's just got corrupted. It's too easy to corrupt it. And one of the nice things about the microservices approach is it's really hard to jump around the boundaries. And microservices allow you to support multiple platforms. So as a result, you don't have to all use the same programming language or even the same programming environment. You can go as crazy as having some C++, some Golang, some .NET, some Java, some Clojure, all different languages and platforms and stuff. That obviously can be a recipe for a disaster if you've got too many, but it can be very useful if you pick a small set that work well together, because different languages and different platforms are better for different kinds of problems. So those are the kind of some of the major trade-off pieces. Although I've written a lot about microservices and I'm very interested in them and where they go, at the moment I'm still, most of the time, stick with a monolith. Only go with a microservice when you feel a real push in that direction. Not all of my colleagues would agree with that advice, but that's still where I am. And I want to finish, though, with, if you are interested in using microservices, there's some really important things you've got to make sure you get before you begin. Not necessarily before you start building the microservices, but you certainly need to have these things in place the day you deploy the first live version. First thing is, make sure you can provision machines rapidly. You've got to be certainly in a matter of hours, not a matter of days, to get a new machine from scratch up and deployed. Obviously, with cloud environments, this makes it more straightforward to do that. Make sure you can do that rapidly. It means automatically. You've got to be in a position where you can go that way, because otherwise you're going to have a whole load of delay in provisioning new machines. This is going to mess things up for you. Make sure you've got monitoring in place. The basic monitoring and making sure you know when one of your services goes down, because they will go down and you will have to react to it. So you've got to have good, decent monitoring there. You've got to be able to deploy your applications rapidly into these newly provisioned environments. Not just the latest version, but again, be able to roll back quickly. So a lot of the continuous delivery stuff I was talking about early on, this is a prerequisite. And you're going to need that DevOps culture that I talked about early on, because this raises the bar and complexity on operations people significantly. So the applications people have to be working together to make this work. If you don't think you can get these things into play with your first deployment, definitely don't use microservices. And this isn't the end, of course. There's a whole bunch of further things that you're going to have to do in order to do microservices any further. And that's it. I'm done.